This tape is on Chapter B. The title of this tape is Scientific Notation Scientific notation is a compact way of writing very large and very small numbers in scientific calculations. This method of writing numbers can often be found in scientific and engineering journals. Very large numbers may have many trailing zero digits. For example, a number such as 34 followed by 12 zeros can be written as 3.4 times 10 to the 13th exponent. Notice several components of this expression. The decimal point is shifted from its original position to a new position over here between the 3 and 4. The 3.4 portion of this expression is called the scientific factor. This portion of it is called the scientific power. The new position of the decimal point in scientific notation is always placed to the right of the first meaningful digit. That's its place always. Here are some other examples. 345.76 is equal to, take the decimal point here and move it 2 positions to the left, multiply it by a scientific power with an exponent. Here is another example. 2 followed by 6 zeros. We can write 2.0 multiplied by a sign, so therefore 10 to the 6th is the scientific power. Another example, we have 274 decimal 532 multiplied by 10 to the 12th. So 2.7, writing the rest of the digits 4532 multiplied by some scientific power. And that is the correct scientific power for that scientific notation. We have been dealing with numbers which are very large, but numbers which are very small may have many leading zero digits. For example, 0 decimal 7564 has 11, 2, 4, 6, 8, 10, 11 leading zeros. Such a number may be written in shorter form and still convey the same meaning, such as in 7.564 times 10 to the minus 12. Notice several components of this expression. the decimal point is shifted from its original position at the left to its new position here to the right. And it's located between 7 and 5. Now, when you look at that number, the first meaningful digit is the 7. And consequently, that is the position of the decimal point in the scientific factor. It is placed just to the right of the first meaningful digit. From your work on exponents, 10 to the minus 12 is equal to remember doing this in your work on exponents. So these two things or expressions are equal to each other. The original number is often referred to as conventional notation. Here are a few more examples which converts very small numbers into scientific notation. Let's take the number 0.00000, 5 of them, followed by 2, 3, 4. So we write the scientific factor as 2 decimal, 3, 4, followed by as sign. Consequently, minus 6 is the correct exponent for this scientific power. Here is another example. Did you count them? 15. Then this is equivalent to 7 times 10 to the minus 16. Here's another example. 0.0078 is equal to 7.8 times 10 to the minus 3. Try this one again. 0.0078 times 10 to the 8th gets to 7.83. But we have 10 to the 8th here as well. This simplifies to 7.8 times 10 to the 5th. One more example. We have 0.00000, one more 0.45 times 10 to the minus 18. 4 as 4.5, and that translates into 10 to the minus 7. When you multiply it by 10 to the minus 18 and simplify this from scientific note, from your study of exponents, we would add minus 7 and minus 18 to get minus 25, so that the final answer is 4.5 times 10 to the minus 25. Take special note of the last two examples. Note the direction in which the decimal is shifted and the consequential effect on the exponent of the final answer. In summary, moving the decimal to the left increases the exponent of the scientific power, and moving the decimal to the right decreases the exponent in the scientific power.